Okay, question number 4 says, a scientist is studying wildlife. She estimates a population of bats in her state to be 270,000. That's the starting amount. Okay, she also estimates or predicts that the population will grow at an average annual rate of 2.9%. All right, when you increase by a percentage, that kind of change is not linear. It is exponential. And so just a quick review, the way we've talked about exponential growth in my class is we have said if you want to find the total amount when exponential growth is involved, you take the starting amount and you multiply it by 1, either plus or it might be minus, your percentage rate of growth raised to the x power. All right, and the key with this is that that percent has to be as a decimal. So in this case here, 2.9%. If we bump the decimal 2 places back, we get the decimal 0.029. And the x in this equation is the time in years. So that's what the general equation is for exponential change when we're increasing or decreasing by a percentage. And so if we want to create a model for this bat population, we could say that y, okay, the total, is equal to the starting amount, which is 270,000, multiplied by 1 plus our percentage rate, 0.029. And we would raise that to the x power. So this should work. I think that they would accept this. It's a good idea to get into the actual testing site so that you can practice using the keystrokes that are necessary to get an exponent of x and so forth. You could simplify this and say 270,000 times 1.029 to the x power, and that would be fine, but this is the basic idea. If you're increasing or decreasing by a percent, you have to take your starting amount and multiply it by a base that's found by taking 1 and adding or subtracting that percentage rate of growth or decay and raising that base to the x power.